Welcome to T-Bug for November 2021. Tonight's session is Getting Started with Testing in Blazor, presented by Nathan Westfall from Tyler Technologies. Looking for other user groups to attend? Please visit meetup.com/.net-virtual-user-group. We're always looking for speakers for T-Bug. If you'd like to do a presentation, please reach out to us at meetup.com/TechValleyNetUserGroup.
And with that, I'm going to turn this over to Nathan.
Cool. Thanks, Chris. I'm excited to talk about Blazor Night. I don't know if we'll need to go till 6:30. While we're talking here, if there are any questions, if you just want to use the raise your hand feature in Teams, I'll try to see it, but I'll let Chris interrupt me if I can't see it. So I'm going to go ahead and share my screen. I am on the road, so we're going to see how well this one screen goes for me. So, all right, so we're going to do getting started with testing Blazor applications or testing Blazor applications. If you've seen me present before, you know me at all. I have been a big fan of Blazor since it was an early preview. I'm much happier writing .NET code over JavaScript. And JavaScript for years has had the ability to do unit testing and UI testing through frameworks like Mocha or Selenium and a few other things. And there's some overlap when it comes to Blazor testing, especially when we get into UI testing. But it's the unit testing that's really starting to take off when it comes to Blazor components. So just to cover a few things, I know Chris covered this, so I'll be quick. The Cloud API role that he talked about is actually for my team. So if you have any questions about it, we are hiring someone to work on our Cloud APIs. We use all new technology. If you joined earlier, you heard us talking about .NET 5 and .NET 6 that we're already rolling out to production. We use third-party tools to help manage our public gateways and that sort of thing. And if you're excited for .NET or excited for AWS, this is definitely the position for you. I am a software engineering manager over at Tyler Technologies. That's why I can say the position is actually mine to fill. Our team is focused mostly on mobile, so anything Xamarin, soon to be MAUI, Blazor, and then we're also focused on any sort of cloud development. So our team kind of leads the way in making sure that our products are set up to be ready for the cloud, whether it be designing new architecture, making it resilient to run 24/7, or really anything else that just needs a cloud work environment. So I'm going to give a quick recap on just what Blazor is for those that don't know. If you're in the .NET community, it's not new. I think it first started coming out in .NET 3.0 or 3.1 for servers, slowly came out for WebAssembly. But what does all that mean? So Blazor essentially lets you build client apps with C#, right? You can build interactive web UIs using C# instead of JavaScript. You can still use JavaScript using interop, and now you can build mobile apps with Blazor with .NET MAUI. .NET MAUI is in this weird state where it's released, it's not released, but when it comes out, it's so exciting to see those two frameworks kind of come together. If anyone's ever worked with Electron, this is how it should have been done. You can run this code either server side or client side. If you run server side, it's just using SignalR to send rendering changes to the browser, so all your C# code still runs on the server. Or if you're doing client side, it actually compiles down to WebAssembly and all your .NET code runs in the browser's VM, which is very cool. And then this allows you to share more code. So Chris can testify to this. So we wrote one mobile app in Blazor, was able to share a bunch of .NET code from our existing APIs, and then spun 2 more up in a week. It wasn't hard to do. It was very simple, and allowed us to really share a lot of front-end code and a lot of back-end code with .NET developers. So Blazor Server, as I talked about, right? So you can host Razor components on the server side. The runtime handles the syncing of either the click events from the browser or the render events from the server with SignalR to make sure that DOM is always updated and the server always knows what's going on. The only downside is the connection to the server is required. So if I lose internet for a second, my UI is going to stop working, right? It requires you to have that good internet connection. Blazor WebAssembly is everything in the browser, right? So this past one, you have stuff on the cloud and then stuff in the DOM. This is everything all in once, WebAssembly talking to DOM, but all locally on your environment. So it's the single page app framework, the SPAs that you hear other people talk about. .NET code runs in the browser and no server is required. So when we built our Blazor apps here at Tyler, we picked the WebAssembly route because they all had mobile use cases. So they all can be work without internet connection. I can one tap install, actually shows as a full page application on my phone, right? There's no browser that opens, no border or anything like that. It looks like it's a native application and runs without it. The only downside is there's a slower startup. Some of this stuff is changing and they know about it, especially with .NET 6. You can have maybe pre-rendering from the server and then switch over to WebAssembly when all the bits are downloaded. They shrunk dramatically the sizes of the .NET runtime and stuff that has to go to the browser. And you can also do some fancy things. So for example, our Blazor WebAssembly apps are all running in a CDN. So really the network latency is entirely up to you from our side. We make sure the code is as close to you as possible when you access the site. And then this is new, Blazor with .NET MAUI. I haven't gotten too much into this. I had an app that worked and just to play around with it, but I'm excited for everything I've been seeing. So you can run the same Blazor components that you do on the web in a native application, as I talked about, similar to the Electron approach. And you can actually combine native and Blazor views. So if you have a brand new app, maybe I want to do all Blazor, except maybe render this one part of it as a native, or maybe I already have a native app with Xamarin, or now I move it over to MAUI, but I want more shared code. I want a website off of it, and I want it all to share the same code. So maybe slowly over time, I take my native UI views, start making them Blazor, and they can combine, live side by side. So that's Blazor, server, WebAssembly, mobile, all .NET, right? But I might be developing these great apps. Maybe I'm doing that MAUI conversion. Maybe I'm building a website. Maybe I'm building a component library, right? There's great ones from Telerik, Syncfusion. We had to develop one internally to hit our UI frameworks. And while I can share all that code, what kind of testing should I be doing on this code, right? I can't just say because it's .NET, I can use all my existing .NET framework testing tools, which in some ways I can, but now I'm dealing with .NET as the UI, right? That's kind of interesting new concept as we go through it. So we have manual testing, which in any form of development we're all used to, right? Did X happen, right? If I ran the application, clicked a bunch of things, did it do what it was supposed to? Kind of the oldest form of testing out there. We have UI testing. UI testing is going to be more of your Selenium. Your, I'm going to load it in a browser, make sure it works, make sure it renders, maybe interact with it programmatically through XHTML tags or some other things, and make sure that I can see it, right? It renders properly. I have the buttons that they're displaying, the text that's displaying, all that. You have unit testing. So unit testing is going to be new when we talk about Blazor components, but unit testing, if you've done console applications, library applications, I'm testing, does my function, if I pass in this, does it return this, right? Those quick, very in a .NET workflow, I can do .NET tests in a couple milliseconds, see did my test pass or not. And then you have integration testing. Integration testing, not everyone hits. Integration testing sometimes is that thing where more and more it appears to be common as more and more people have to develop public APIs, right? So you're either testing your API to make sure that the data comes back correctly, or you're mocking integration somewhere and really just testing how you interact with that data. The two we're going to be focusing on is going to be UI testing and unit testing. Those are the two in Blazor that we're going to test today. Integration testing doesn't really apply in some of the cases that we're going to go over, and no one needs to come to an event to watch me do manual testing. That doesn't really give anyone benefit. So UI testing. So this allows us to test the UI in an actual browser on a device to ensure it renders and operates correctly, right? This could be Safari, Firefox, Chrome, Opera, whatever browsers that are out there. Maybe I want to make sure it works on a 27-inch monitor, a 15-inch monitor, emulate it for a mobile phone, Safari on an iPad, those sort of things. Make sure that JavaScript is the same. Make sure that the dimensions work, my code resizes, my UI resizes, make sure that all that works. The pros is that there's plenty of recorders to easily write this code, right? There's plenty of point and shoot, point and click tools that I can run that actually help me write the code, right? So I can hand this off to someone maybe in my QA department, someone with very little knowledge, and say, let's move some of your manual testing to UI testing. All you have to do is do the same manual test, but with this recorder running, and then give me the code that it outputs, right? So you can kind of speed up that cycle or give it to someone that's not a developer. You can have a high level of confidence when running across multiple browsers or devices in browser configurations, right? So you can basically say, I didn't just test the rendering or the ins and outs of this component. I actually opened it up on a physical browser on a physical device and made sure that it worked. And sure as heck beats manual testing. Cons, so small UI changes are more annoyingly when you get with developers that haven't done this before. XPath changes, ID tag changes, right? Stuff of how I reference what's on the screen can break these tests, causing kind of a maintenance nightmare if you're not done doing it correctly. And this requires the application to be deployed or at least running. And most of the time, depending on your applications, we all have a data set behind it, right? We have a SQL database, MySQL database, maybe SQLite. But the application needs to be running in order for me to hit a URL and then access it in the browser. The tool we're going to use to go over this tonight is actually Microsoft Playwright. I prefer it well over Selenium. I think for a .NET workflow, and even if you just want to do UI testing in general, they built it for Node and moved it to .NET. The recorder for it is great. The tools for it are great, and it beats setting up Selenium. If anyone here has ever set up Selenium, you know that it gets really complicated when you have grids, you have to install browsers, and when you have all these headless configurations, meaning the browser doesn't actually display, how does that look? It can get pretty complicated, and Playwright kind of takes all that out of it. And then we have unit testing. So this lets us test the functions or the components in your application without actually deploying it, right? UI testing, as we just talked about, I have to deploy the application. I have to make sure it's running. Then I open it in a browser. You don't have to do that with unit testing. So pros, it can be very fast since you don't have to wait on a browser install, a browser launch, page switching, network latency. Even though it's all local, all these things add up when you have a few hundred tests. And it does not require the application to be deployed, right? So if you think of a CI/CD pipeline, maybe I have to make a change. I then have to run it, just my PR. How does that look like? Then I have to run my UI test against that. You don't have to do that with unit testing because it doesn't actually need to be deployed. Cons, it's harder to visualize changes when testing components because you're not actually rendering anything, right? You're asserting values, making sure that they're correctly. And this, while we can have some confidence in the browser, you're really putting all your trust that the browser renders correctly. So if I say background color is red, I'm not testing that it shows red. I'm just having the confidence that I was able to change that value background color, and I'm putting my trust in the browser that it can distinguish that value and do what it needs to do. The framework we're going to use for this tonight is going to be BUnit, and the unit test is actually what I'm going to cover first to go over. We are going to do both behind the scenes with XUnit. So if you've done anything before with .NET testing, then some of this should look familiar. We're really just picking different frameworks to make sure that we can take the UI elements and test it with XUnit, and we can take the Blazor component rendering or non-rendering with BUnit and plug it into XUnit. So, and with that, I'm going to jump into some actual code. Any questions before I keep going here? No, I think we're good. Okay, let me back out of all this as I'm preparing here. So I have a very simple application, and this code is available on GitHub. So as I'm going here, know that all this will be available when it's done. So I have my app, right? It's going to be a very simple app. I create a server and a WASM application. It's really the example when you do .NET New Blazor with some few changes. But I wanted to show you as well that all the testing that we're going to do today can apply to both server and WebAssembly. And it's awesome to see as well, there's no changes between the two, right? You can test both with the same test library. You don't need to have one or the other. So let me just go ahead and boot one of them up. I'm just going to do .NET run. Let it go ahead and build and then open up a port for me so I can take a look at it. I'm going to open that up. As you can see, it is the default Blazor app that if you do .NET New, you get, right? So I have a hello world, I have a counter, I can fetch some data, just a local JSON file, right? And make sure that this all works. So agreeing, right? This all works. This is WebAssembly. It's all running without the internet. I can close it and it would still work, right? So this is exactly what we wanted. So, but I want to test this, right? I want to see what it actually looks like. So just because I'm traveling, so I wanted to make sure I had everything downloaded. I set up the projects, but I didn't write any of the code. So if I jump into WASM and I just look at the CS proj running .NET 6, for BUnit, this is an important thing. You just have to change your project from Microsoft SDK to SDK.Razor, because when you do .NET New XUnit, which is one of the projects you can do, if we look through here, right, of all the projects that .NET New lets you do right off the bat, I just did .NET New XUnit and picked my solution. You just have to change it to Razor for BUnit, right? Because they actually want all the Blazor components there so that you can do the rendering. So running in .NET 6, I added BUnit as a package, and that was it. Everything else was already here. Microsoft took care of it. All I did was say, also include BUnit for you. So BUnit allows a great way to do things, right? So if I look at the code for WebAssembly and I look at the counter page, for example, right? It's a Razor page, right? So I have my attribute at the top, letting it know what page I'm going to. I have a page title defined. I have some HTML standard, right? And then I have my actual C# code, right? I have an increment count. I added a custom one called reset count. And obviously, you know, if I click the button, click me, it's going to call the function increment count and just up that count 1. That count is referred to in the UI, and we'll see that go from 0 to 1 to 2, so on and so forth. I then also have a public method that's not available in the UI, but I want to make sure that if I call this component and I call reset counter, reset the count to 0 and display that accordingly, right? With BUnit, this is a benefit of BUnit over UI testing. There is no way, unless I exposed reset count in my UI, to actually test that function, right? This is a function that another component can call, another part of the .NET runtime can call, but there's no way when I load this in a browser, I can call reset count without having a button or something like that. So what we're going to do is actually test this component. We're going to test a simple hello world one, right, just to show what it looks like and see how we can test those. So with BUnit, you can write tests either in C# or in Razor. So for this hello world one, just to show how simple it is with Razor, right? So it's I'm creating my own component, and I'm saying this component really is just a header 1 tag that says hello world from Blazor. Nothing crazy. I have a test, hello world Razor test, right? And in here, I am just saying, you know, I don't have any HTML code, it's just Razor code, but I'm going to have a test that says hello world renders correctly. And if you've used XUnit, I had an attribute fact. That's how I know it is a test. So first thing I have to do is I'm going to call in my context, right? So I'm going to call in a new test context, right? From that context, this now allows me to do rendering of components, but I can render the same way I would do up here, right? So if I wanted to call hello world, I would simply do hello world, right? Because I wrote it as a component, so that's totally valid the way that I wrote it. But I want to test it, so I'm going to come down here and I'm going to find the component, and I'm going to say, with my testing contest, render hello world like that, right? So now I'm rendering my component and I'm putting it into a variable, and now I just want to say simple assertion, does my component, does the markup of that match a header 1 that says hello world from Blazor, right? And does that work? That's what I'm after. So if I go to BUnit, and I look at my tests, now I do .NET tests. Hopefully this works. It's going to run this one fact, to run this one test. Hopefully it doesn't yell at my other one. Find out real quick. Boom, there we go. It passed my test. All these other tests come back as passes because I have them marked as fact with no code. But my code came in here, right? Let's say maybe I came down to my component and I changed it and I said, you know what, I really want this to be a header 2 tag instead, right? I come here, run my test, and I should have there you go. See, one of my tests just failed. Same output we would normally get, and it's saying, yeah, you know, the actual was a header 2, but you were expecting a header 1. So easy test to write in Blazor. Now, maybe I'm more familiar with C#, which personally I am. I would prefer to write tests in C#. Blazor's great, but for testing, you're kind of stretching my patience at that point. So we're going to do a few things, right? We're going to write the same test, make sure that the counter component renders correctly. We're going to make sure that counter renders correctly after some clicks. And then we're going to make sure that the counter component renders correctly after clicks. And I call that method reset counts that's not available in the UI, right? So again, to make sure it renders correctly, very simple. I'm just going to call in the test context. Test context. I'm going to render my component. Render component. I can use T types now because I'm kind of in it. And then I'm going to say that my markup matches, and I'm going to steal this from the server once they're written. I'm going to say that the markup matches this, right? So there we go. I'm going to say that the markup comes back with that header counter. There's a new line, comes back with current count equals 0 because I didn't hit click me, right? So the count should be 0, and that the button is still on the page, right? So if I do .NET test, since I fixed that last example, we should still have all 4 tests completely passing. Perfect. Okay. So let's do the same thing down here, right? So I'm going to copy this down here. And then maybe now that I want to check it after it clicks, what I have to do is I actually have to find that button, right? There's no browser, right? We haven't seen a browser launch, anything like that. There's no browser. So I want to see what happens if I can reference that click me button. Now, I don't want to call the function. I actually want to, in HTML, find this button and actually click it as if the browser was there. So I can come down here. I already have my component defined as cut. I can say, let me get the button, and the button's going to be cut, find, button, right? Maybe this is an ID, whatever. I only have one button on the page, so I'm just going to say, find that button. And I can easily do button elements dot click. And now I just found that button, and I was able to click it, emulate a click, just like I would in the browser. So I'm going to come over here, copy this, and since I clicked it, the current count should now be 1, right? I'm going to go ahead and test this. As you can see, too, this is very quick to iterate over, unlike a UI test, right? I just ran this 25 milliseconds for my tests, 4 of them. I just tested that a current count was 0, a current count was 1, just to show that I'm not lying. I'm going to make this 2, so that way it should fail, that I actually clicked the button and it actually is 1. I went ahead and failed. And it's because the actual was current count is 1, not 2. Maybe I want to test it when it clicks twice. So I'm just going to click the button twice now, run the same test, and my current count should be 2, like I think it is. There we go. Okay. Now I want to call that reset count, right? So let me just copy this again. We're starting from the same spot. All this is true. Right, so I clicked 2 times, my time is 2, but now I want to reset it. So I'm going to do cut, and now I can actually reference the instance of that component. So I can type in instance dot, and now I can call any function that I have in that component. So my function, if we go back to it, you'll see is called reset count. So I can do instance dot reset count, and if I check, it should equal 0. So I'm going from 0. Clicking the button twice, then my count is 2. I'm calling this method that I created, not exposed in the UI, called reset count. And now it should update the UI and set it as 0. So if I do .NET test, go ahead and run this, we will see very quickly that I wrote something incorrectly. And that is, but even though reset count is there, just make sure just going to call this just in case something weird's happening. See what happens. Make sure that goes back down to 0. Nope, this was working earlier. But either way, you can see that you can at least call the function, right? It doesn't error out saying this function doesn't exist or that the function is inaccessible, right? I don't have to go put a fake button or a hidden button on my screen to call it. I can have these methods that are in there and actually access the instance itself. What we'll do to see if this one works, so if I go back, I have all the same tests in a server test application. So the only difference is in my WASM one, in my WASM test, you can see I'm referencing the WASM project. In the server one, you can see same thing, just referencing the server project. All my tests are the same, right? All of it's still there. So I'm going to go ahead and run that. So I'm going to do testing server tests .NET test. Hopefully this comes back with 4 successful, and I'll figure it out later. You'll see all of them passed, except for this one. There you go. But you can see same code, right? So I have the same exact code between server and WebAssembly, and both of them will work the same way. If it does, then this should fail. Yep, see, so it fails. But if I take my WASM test, so I have nothing crazy except WASM up here. It's the only thing. I'm going to literally copy this entire code. I'm going to delete this, put it in. I'm just changing this to server since I'm referencing a different project. And if I run it, we should have 3 pass. Yep, my test ran the exact same way, did what they were supposed to do, and I didn't have to like render a server one differently versus WebAssembly. I didn't have to load a server or do something like that. I got it to all work with the same code. And again, this stuff is great. You can kind of start to picture some of the real world use cases here, right? So we use BUnit for testing in our applications for the shared component library, right? I want to make sure that when I build a component, I'm not the one designing it, so I'm trusting the design is there. I'm really calling into someone else's, but I want to make sure my abstraction of that component works inside out. I want to make sure my functions work. I want to make sure my touch events work, my scroll events work, my focused event works, all those sort of things. Put those in tests so I can have a high level of confidence before I distribute this UI library to a bunch of developers that my tests work. And again, they run extremely quick, right? It's not like a UI test, which we'll get into in a second, where I have to wait around, which while still fast, I only have 4 tests. You can imagine a few hundred tests in a UI library. It's going to take some time, right? So, all right, backing out of all of this, let's move over to Microsoft Playwright. So any questions so far before I switch over? Cool. Okay. So with Microsoft Playwright, again, I just did the same thing. I created a simple one. I didn't create one for server and one for WASM like I did for BUnit. This is because, as you can see, I'm not actually referencing the project. What I am referencing, if you look at my little helper file here, I'm just referencing a site, right? So I don't care if it's WebAssembly. I don't care if it's server. We'll switch around both. I'm pointing to a server, to a URL, and that's what I'm testing, right? A few other things I set up that I just want to cover. It's kind of maybe a little more advanced what we're trying to do today with getting started with Blazor testing, but I wanted to kind of explain where my head was at for someone that might be following. So all I did was .NET New XUnit again. I installed Microsoft Playwright. I don't have to do the project change like I did last time. All I did was add Playwright as a NuGet package. I'm using another library, which you can also use for BUnit. It makes better demoing, honestly, in Playwright to show it. But there's another library out there called Verify. Verify is a great way to write your assertions without actually writing assertions. And we'll kind of show how that works, but that was the other piece I added. The other thing I added was there's a CLI that you can install. So you do .NET tool Microsoft.playwright .CLI, and you install that. And it basically gives you a little command line tool that you are able to use for Microsoft Playwright. So if I, write Playwright, it's going to, give me a bunch of stuff back that I should have done, right? So maybe I'm taking a screenshot, showing a trace, I'm installing my browser dependencies, right? So if I have a new dev machine that I've never used Playwright on before, I can install the CLI, do Playwright install, and boom, and make sure that Firefox, Chrome, Edge, Safari, all of them are installed, all of them are set to go, dependencies done, and I'm ready. Makes it really easy. Two other files I wrote just to show. So I wrote this Playwright fixture. This is kind of from us using it with other code that we've written. It's really just a way to save some code when writing Playwright rather than do it time and time again. So I have an instance of Playwright. I have my Chrome browser, my Firefox browser, my Safari browser, and then my verify settings, right? I initialize this, which we'll show in a second. And all this does is basically set up Chrome, right? Playwright.chromium gives me my Chrome browser, gives me my Firefox browser, my WebKit or Safari browser, and then a few other settings I just didn't feel like setting up every time. I also created just a simple setup function, which you'll see in a second, that will get the browser based off of the one that we want, right? Do we want Chrome, Firefox, whatever, and gets that new context. So this allows me to pass in different devices, right? Maybe I want to launch Chrome as an iPhone. Maybe I want to launch it as an iPad or a web, and be able to configure that. I can also configure the language. So we're not going to get in that today, but you can actually set a browser to French, set it to Spanish, and actually make sure that your page has that multilingual support automatically built into it. And then just give me a new page back. That's all this does, is load what's there, get a new page, go to the base URL, and say, boom, now you're ready for testing. The other one is just this verify test. So there's two types of verify tests that we're going to use. I'm going to validate the HTML, and I'm actually going to take a screenshot and verify pixel by pixel to some degree of confidence that it's the same rendering on both screens, right? So I don't need to assert 1,000 things on a page. Does the title match? Does the menu match? Does this match? Does this button 20 pixels? Is it blue? I don't have to do that. I can compare the HTML, I compare the image, and I can have that level of confidence that it is all there and working. So that's all this does set up. I don't want you to make you think that there's a bunch of magic behind the scenes or anything like that. It's really just two helper files that we took from somewhere else to kind of just speed some of this up. Not needed for tonight, but helps show it out. So this looks pretty familiar, hopefully, as a XUnit test, right? So I'm just saying it's a class fixture. There's the fixture that I wrote before. And now I have the code in here that I want to write. So there's two ways I can write code. So we're going to write the same exact test. Again, I can't do that reset clicks one because that reset clicks is specifically a hidden function. There's no UI, so I can't do that. But I can make sure that the counter renders correctly, and I can make sure that it renders correctly after a few clicks. So first things first, I have to get the page, right? So I'm going to do page.await this.fixture, and then I'm going to set up my page, right? So I'm going to pass in language, browser, and device. Again, this is a class that we wrote. All it's doing, though, is getting a browser and then returning a page. iPage is the interface iPage that you interact with here is really all that matters. That's the part that you care about. Once the browser is set up, all of your interactions are done with the actual page itself. So now we can interact with the page, right? So let's say, let me actually run the application so we can kind of visualize what we're doing here a little bit. Let me go ahead and run it. What I want to do is, because I go to the default page, I actually want to first come to counter. So what I'm going to do is, I'm just going to use simple text finders here. I want to click counter. Excuse me. I want to click the counter and bring myself to the counter page. So I'm going to say await page.click async, and I'm going to say text equals counter. All of the paths you can put in here, they can be XPaths, they can be IDs, they can be a number of different things. All of them are pretty much shared. If you've ever used Selenium or anything else, they're kind of going to be the same format that you're used to. So I'm going to say click counter. Then, not that it's required, it will be when we do server, but I'm going to say, wait for load state async. And what I'm saying is basically wait for the network to be done talking, right? Maybe there's images that has to load, other CSS files that have to load. For Blazor Server, right, I have to wait for that signal R connection while quick to complete. So just to be safe, I'm just going to say, hey, wait for the network to be done doing its thing. And then, because all I care about is that the page renders correctly, I'm just going to say this.fixture and verify the page, right? So verify the page, language, browser, device. right? And all this is doing, if I go to this verify page again, just to show you kind of where we're going, verify takes over from here, right? I pass in the page, the iPage element that we were talking about, and some settings that got passed in. So I'm saying, hey, I'm done with this test. Take this page, grab the HTML, grab the screenshot, and show me what happens. So I'm just going to uncomment this test to show you here. And again, I have to have it running. So I'm going to get my new URL here, since we grab random ports now in .NET 6 apparently. Put it over here. And now for Playwright, I am going to run this. Now I did this not in headless mode, so you can see everything happen. So now that this is going to run, we should see in a second here, Chrome is going to open, right? So, or Firefox first, right? So it's going to open this, create my page. It's going to that URL we were talking about. Clicks counter, done. Goes to the next one. Now we're in Safari, boom, clicks it, done. Now we're going to launch Chrome. Same thing, load it. It's going to click counter and boom, done. Now you can see my test failed. They didn't actually fail. We all just saw it, right? I click counter, the page loaded. It's exactly what I wanted. With verify, when you write a new test, there are 2 steps you have to do. 1, write the test. You can check that off, we're done. The next one is we actually have to verify the data. So this is, again, this is what makes it nice for a QA person. They have this concept of a received file and a verified file. So the received is right here. This is what actually came back when I ran my test. When I came back in my test and said, hey, verify this page, it took an HTML snapshot and it took a screenshot of what happened. I can come in here and look at both these and say, yep, they're good. I'm now going to say that both of these are verified. So I'm going to say verified, right? Come down to all these. I'm assuming that my code works. So I'm just saying that all of these are basically the test in the verified state. You can then check this into GitHub. You can check it in with your source control and keep your tests close to the code. So now if I run this again, we'll see everything happen. We'll see these browsers open back up. Notice how they cleaned up after themselves. That's something else we did with the test fixtures. Boom. Next browser. Again, way faster than manual testing. I don't want to have 3 browsers open doing all this work, right? I can just have this be done automatically and just compared. All my tests passed, right? It took the verified data with what was received, compared it, and then off to the races it went. What is nice is that you can compare just HTML, just PNGs, text, whatever you want, and do it side by side. You can also, I took it out for this example because I didn't want to see it, but you can also have it open tools such as KDiff, VS Code's diff tool, if something were to go wrong. And you can actually just immediately see, oh, you know what, this one line changed. Yes, I want version B instead of version A, and it'll take care of the verified state for you. So pretty neat, right? Saves you a lot of time. It's better than writing assert this, assert that, or with bunit markup matches, you have to type out the whole HTML. You can just use verify, look at it once and say, yep, I'm good to go. Now, the next test we want to write one that runs after multiple clicks. So now I'm going to interact with the page a little bit more. So I'm going to grab this code because we still have to go to the counter page, right? I'm now going to say, what is the button? So if I look at the page, there's a button that says click me. This is what I want to click. This is what I want to show up to happen. So what I want to do is say await page.click async again, where the text is click me. Now this has 2 benefits, right? So this will not only click the button that says click me just by the text, it'll error out if click me is not on the page. So I know if I get an error when I reach 46, it means click me actually was never on the page to go ahead and click. So I'm going to click, let's say 3 times, and now I'm going to verify this page. So I'm going to go ahead and run my test again. Remember that they're going to fail, right? Because I'm going to get received data, then I'm going to mark it as verified, but we're going to let this run. And we're going to see why. Oh, yeah, because I did .NET test instead of what I actually should have done. My bad. Passing in that nice URL. That's why I wrote this. Should probably use it. So now it'll run, and now it'll launch my actual tests. So we'll see which one this is. See all the counts are 0, so they're not happening yet. It's going to actually reuse the browser, which is nice. So it's going to kind of create a new page for me. Boom, 3 times, 3 times, and 3 times, right? It's going to do all that in the background here. Wait for it. Click it 3 times, and there we go, right? Just as I expected, 3 passed, 3 failed. I can come down here, set all of these as verified. Maybe I check my screenshot, right? Look at that. Nice little current count equals 3. We like to see it. So I'm going to mark all these as verified again. Verified. And verified. All right, so I'm going to go ahead and run it one more time. Be a lot quicker this time. And do it this way. I'm running it again in non-headless mode, meaning that you can see what it is. If I ran it in headless mode, you wouldn't even see the browsers launch. They kind of run as a worker service in the background. Still render it, still do the same thing. It's not a unit test where it doesn't render it at all. Still requires the browser to render it, but I don't need to watch it, right? That's what it's kind of saying. There's also other settings you can do, like maybe I want to slow the interaction down. So I want to put a delay between each of my actions. So if it's a very complicated workflow, I want to see it click. I want to see what happens, see what it types, all that sort of thing. So there we go. So we just had 6 tests pass. Now, this is even the coolest part of Playwright, right? So I wrote 2 tests by hand. We've just wrote a whole bunch of tests in maybe 35 minutes or so. Really not that hard, right? Anyone can write unit tests or everything. Now, let's say I hand this over to someone who does not write tests, right? Who does not write code. I can do Playwright code gen, going back to that CLI tool that Playwright offers. And if I type Playwright code gen, it's actually going to open 2 different browsers for me. So I have the actual browser on my left, and then I have this nice recorder on the right with code, right? So I can say I'm going to target C#, Java, JavaScript, right? So I can, boom, code just changed. JavaScript, again, code just changed. But we're going to use C#. We're in C#. So you can see some of the code, right? So it's saying use Playwright, launch Chrome. It did that. It's not headless. That's why I can see it. I want a new browser context, and then I want a new page. And there we go. I'm right where I am. Let me go ahead and grab this URL. I'm just going to grab the base URL just like we would in our test. I'm going to put that in. I'm going to go. Oh, as you can see, not only is it loading, it just wrote the fact that I'm going to go to this page. I'm going to come here. I'm going to hit counter, right? Look at that. Same code I just wrote. Click async text equals counter. Pretty cool. I'm going to hit click a few times. You see as I hover over it, you can see that the attribute below it is letting me know what I'm actually on. I hit click. This one's even better code than me, right? I'm going to click it 3 times and actually did it 5 times, but you get the concept, right? So there's a nice little helper for that. Maybe I want to go back to fetch data, right? Maybe I want to go back to home and then maybe back to counter, click it twice. More time so I get that nice fancy code. No, it's not going to give me that. That's fine. Oh, it's because it's double click. I didn't even see it. So we'll say 3 clicks. There we go. And then I can stop recording, right? I can also do some weird things, start recording again, and then, pick up where I left off if you wanted to, but that's pretty good. So I'm just going to copy this code. And since we already have a page, I'm just going to copy from here down, or actually here down, because we already have the URL in our code. So I'm going to copy this. I'm going to come here. I'm going to say public async task, and I'm going to say debug live recorder test. String language, string browser. You don't have to do all this. It's just again for the helper that we've written, and put all this down here, right? So get the page. I'm just going to grab this page real quick from my fixture. I'm going to verify the page when I'm done. Or not even, we won't even try to verify at this point just to save time, but I'm going to grab all this. And now when I run this, I should get 9 successful tests. It should actually run this exactly like we wanted to. So if I go ahead and run this, so sh. Go ahead and let this run. We should see it. Yep, see, so already have some fun tests. It's going to run my fun ones first, right? It's going to jump all over the place and do what we wanted. So it's boom, weather forecast, home, counter a bunch of times. And I didn't actually have to write any code, right? I literally copy and pasted out of a recorder and put it into my test. So you can hand this off to a QA person. We've handed it off to people who have never really written code before. They have their tests in their existing manual test regression library, right? Maybe TFS or Spirit Test or something like that, Jira. And when they are done with their test, they can just paste the code for a developer and say, hey, here's my test, go ahead and automate it. And there you go, right? I have a confidence that I now just click the counter, clicked it 3 times, fetch some data, hit home, hit counter, hit it 3 times again. It even offers me suggestions of assertions, right? Hey, after I click this, I should make sure that the URL is equal to this, right? And some of that sort of thing. So very cool on how all of this works. Any questions before I leave the demo? Cool. Okay. Going back to presentation as we wrap up here, and then I'll have some time for questions at the end. So just a quick recap of what we did, and I know we went through a lot. So BUnit, right? We can quickly unit test functions and components without the need for a browser, right? We didn't have to launch a browser like we just did for Playwright. We were able to just go through it without having that extra overhead. Can interact with methods of your components that aren't exposed in the UI, right? So I was able to, well, it didn't quite work, but I was able to at least use that method reset count without an issue. I was able to call something that wasn't exposed in the UI. I can run tests quickly on any machine. I don't have any installation, right? Playwright, I have to make sure browsers are installed. They give me that CLI that makes it easy, but with BUnit, if you have .NET for your project, you don't need anything else installed. And then the application itself does not need to be running in order to test, right? For server or for WASM, all that sort of stuff for Playwright, I had to actually .NET run the application, grab the URL, and use that for my tests. For BUnit, I didn't have to do that, right? I didn't have to go run the test. I could close it out and still run and render my components. Microsoft Playwright, right? So I can test my UI across different browsers, devices, screen configurations, right? We just did Firefox, Safari, Chrome, all at once with one test, just change the browsers around. I can interact with the UI directly, just as the user would. Tests can run anywhere a browser can, right? Minimal installations, anywhere a browser can run, that's where I can run my tests. And the application, though, does need to be running in some way in order for the test to run. If you have some things with .NET Core, you can actually just have the test application do that like web hosting builder, right, and run it yourself, or you can have it run somewhere else and just hit that other URL. So what's next? What can you do? How is there a practical use case for this? What are some things that you can take this testing and go back with? So how can I use this for the real world application? So UI and unit tests for full web applications, right? This requires fewer manual tests. Even as we saw, maybe I don't want to do unit tests right away. That's more developer driven. I want to do UI tests. Giving that recorder to someone does not take a lot of effort, right? Setting up a new project to just hit some edge cases, maybe I write it for bugs only, using that recorder is a great way to get started. The unit test can start using those shared components for confidence before sharing with other developers or teams, right? So we have a lot of shared Blazor components. We have one for our UI. We have one for interacting with local storage, with interacting with the location services API, right? I want to unit test those, don't necessarily need to render them, but unit test them to make sure that I can have some level of confidence before I share those libraries out. You can unit test interop even, right? So we didn't get into this. I didn't want to overcomplicate with some JavaScript, but you can test the interop to make sure that your JavaScript and your Blazor application properly talk back and forth and that they can handle those elements. A few libraries that we cover just for links, right? So you have XUnit. XUnit is a great way to do testing. I know there's NUnit, there's VS Test. XUnit is personally my favorite to work with. You have BUnit. BUnit also loves XUnit, hence the name. So a lot of BUnit does plug into XUnit. You can use NUnit, BUnits to do that unit testing of Blazor components. Microsoft Playwright. There is a version for JavaScript for anyone that cares. So there's a few different versions of Playwright that exist, but the .NET one is the one that we used. That includes the recorder, that includes the NuGet package, and there's a whole bunch of stuff you can do. I would encourage, if you're interested in Playwright, to just go to the docs page and see all of the cool things you can do. You can do location emulation, you can do JavaScript emulation, you can do multiple tabs, multiple browsers. How do they interact if I click something here? Does it live update on my other page? It's incredible what you can do with some of the configurations that Playwright offers. And then you have Verify. Verify is that quick way to do assertions without doing a bunch of, find this text, does it equal this? Yes. Does it equal this? Yes. And Verify is a quick way to add. So a QA person going through that workflow uses the recorder. I copy and paste my test. I say, boom, hey, let me just run this through Verify. And the QA person can just check those screenshots and say, yes, 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 boom, all of them are verified and my tests are done, written, and shipped. Few new things in .NET 6. I like to cover whatever's new in .NET when I cover Blazor because they're always making improvements. So some of this is related to testing, some of it's not, but just to encourage more people to start using Blazor. .NET 6 literally came out yesterday for GA release, so start using it. It's a long-term support version 2, unlike .NET 5, so you have 3 years that you can use it for. So WebAssembly AOT compilation. You can actually make the startup time faster by doing that AOT ahead of time. Your binaries get a little bit bigger because of JIT, so there is some trade-offs, but your runtime is faster. SVG support, I put this on here specifically for Chris because Chris loves SVGs, so I wanted to make sure that he knows in .NET 6, yes, SVGs are supported in Blazor. And I'm sure you've already found a shape that doesn't work. Error boundaries. So right now, if an error occurs in .NET in Blazor, you kind of have some control over it. You can put something at the bottom, but they really added different ways to do error boundaries. So if it's a certain type of error or you want it somewhere else in the UI, you can control where it goes, make it look a little nicer, and handle those errors better. Head content control. This doesn't sound like anything, but a very annoying thing that came out. If I wanted to click a new page because it's SPA, I'm not actually going somewhere else, but I want to update my title tag in the header, that now has native support. You don't need to pull something else in or do something weird. Improved accessibility. So I haven't played around a ton with this yet, but it's very cool to see how they're doing more and more accessibility in Blazor for imperative healing, the blind, to make sure that your SPA application written in .NET has the compliance it needs for public-facing web applications. For library developers, so I was talking about we write a few libraries, you can now have required parameters. I cannot tell you how many times I have to null check or do something on the function on initialization just because a parameter is required. So now you can define that directly in your component. And there's a ton more. There's a ton of new things that have come out with Blazor. You can do file uploads better, file downloads. They do byte conversions between the JavaScript interop and Blazor. You have faster JSON serialization times back and forth. They really did a lot of work in .NET 6 to bring it up to what you would expect in a SPA application. So to get started, there's a few things, right? Go ahead and check out Microsoft's website. Go to .net.microsoft.com, find the Blazor section, start looking there. You'll see references to unit testing. Still check out those GitHub links for BUnit, Playwright. And then tonight's code is on GitHub. So everything we wrote tonight, you can go ahead and run. It doesn't take much, right? So as long as you have browsers installed and .NET 6 installed, you can run .NET Build, .NET Test, .NET Run, and boom, you're off. You're running test, everything that we ran tonight. And that is it. So with that, I appreciate everyone for coming out, for hearing tonight. I hope it was helpful, kind of see how practical tests can be. And I'll stick around for a little bit to make sure that there's no questions or anything like that. And it can be either about Blazor testing, how we use it in the real world for applications, any and everything.
I have a question.
Mm-hmm.
So if your app requires the user to authenticate, how do you get around that?
Blazor does have direct integration with OIDC providers. So there's a NuGet package you can pull in. I think it's actually just Microsoft.webassembly.authorization. And you can set it up just like a SPA application. So I know they're getting better with some of the things that you can do maybe in like MAUI and those sort of things, right? Like I think you still have to technically write a native view in MAUI if you want to handle those authentications. But if you follow OIDC or any of the OAuth patterns out there, and you use like implicit flow, like you would in a regular SPA app, Blazor fully supports that. It's not a ton of work to set up, so you can start having like authorized pages. So this page requires authorization, this one doesn't. You can use what you're used to in regular .NET Core, where my identity context, my user principal, right, is accessible on these pages, so I can pull in usernames, that sort of thing. And it's pretty trivial to. It's not that hard to set up. You can get it done very quickly. Their docs are well written. And they really follow the SPA pattern. So if you've written SPA apps before, understand how they work, Blazor tries to follow that same train for you now. That's a good question. Anything else? Cool. Chris, back to you then.
Alrighty. Thank you all for attending.